Imagine a world where materials themselves think. This isn't science fiction. It's the reality researchers are building with soft, flexible materials capable of complex calculations. This innovation could revolutionize everything from robotics to sensor technology. Researchers at the FOM Institute for Atomic and Molecular Physics, AMOLF, in the Netherlands have developed an elastic metamaterial that mimics the computational abilities of computers, specifically performing matrix vector multiplications. This breakthrough utilizes floppy modes, movements that require minimal energy, to achieve these computations. But how does it work? Instead of relying on rigid electronics, this material is designed with repeating units. By carefully controlling the design of these units, researchers can dictate how the material deforms, enabling it to perform different calculations. Even more impressively, the material can be reprogrammed after it's been created. This opens up exciting possibilities for creating smarter soft robots, incredibly small mechanical sensors, and advanced devices that process information directly within the materials themselves, bypassing the need for traditional electronic components. The challenge of traditional computing. Traditional computing systems separate the physical world from digital processing. Information from the physical world, motion, light, sound, is converted into electrical signals, which are then processed. However, each conversion step consumes energy, introduces delays, and can result in some information loss. Researchers are now exploring alternative methods to compute directly within materials, circumventing these conversions. Mechanical matrix multiplication. One key operation in machine learning is matrix vector multiplication. Mechanical systems, especially those using soft materials, offer a low-power alternative. The challenge lies in controlling their movement. The solution? Floppy modes, motions that require almost no resistance. These modes guide predictable deformations, enabling efficient computations. The researchers created a soft mechanical metamaterial, a rubber sheet with a repeating pattern, to perform matrix vector multiplication using these floppy modes. Inputs are applied as horizontal or vertical displacements at the sheet's edges, and the outputs appear as movements at other edges, matching the result of a matrix applied to the input vector. The sheet is made of small tiles, each mapping 2 inputs to 2 outputs. Beam angles set tile weights and can be positive or negative. Simulations account for real-world bending and stretching, ensuring accurate and low-energy computations. The elastic intelligence material. The performance of this soft mechanical metamaterial is limited by the beam aspect ratio, the ratio of the length to the width of each beam. Larger angles, which could create bigger matrix weights, also stiffen the input path, reducing motion at the output. Calculations suggest that matrices up to 64 by 64 can be built accurately with current microfabrication capabilities. This is sufficient for tasks such as speech feature processing. A prototype was tested using 6 mm rubber. Stepper motors applied small boundary motions tracked by cameras. Individual tiles followed the expected linear mapping with approximately 20% error for small inputs. Weights can be adjusted post-fabrication, allowing some matrix entries to switch between positive, negative, or 0. And this is the part most people miss. The team's work demonstrates a deformable material performing matrix vector multiplication directly through motion, without requiring electrical conversion. Controversy alert. Could this technology lead to a future where everyday objects possess a form of intelligence? What ethical considerations should be addressed as we develop materials that can think? Share your thoughts in the comments below. This article is based on research published in the journal Advanced Intelligent Systems.